Okay, so on 2.1 day 2 notes, we're going to be using our biconditional foldable because we're going to use definitions written as biconditionals. We're also going to use prior knowledge of terms that we learned in chapter 1. So you could use your chapter 1 summary, which has all the definitions of the terms on it. It was on the front of your chapter 1's note packet, or you can use the glossary on the textbook's website. So example 4 says, decide whether each statement about the diagram is true. It wants you to explain your answer using definitions you have learned. So first of all, this symbol right here means perpendicular. So let's just think about what we know about perpendicular lines. What we learned is that two lines are perpendicular if and only if they intersect at a right angle. Or if you want it as an if-then statement, if two lines are perpendicular, then they intersect at a right angle. Or if two lines intersect at a right angle, then they are perpendicular. So those are all fair statements to make. So if you look at line AC, that's this line right here, and line BD. Now notice it has the right angle drawn in. So it is completely okay since it has that right angle drawn in there. We know it is a right angle. So we are going to say, yes, it is true. Now our reasoning, I'm going to try to use everything as a biconditional statement because that's how in the future I've written all your definitions as to use for proofs that we have coming up. So our reasoning is two lines are perpendicular. I'm going to use the perpendicular symbol too. If and only if, remember that was the abbreviation we were trying to use. So two lines are perpendicular if and only if they intersect at a right angle. At a right angle. So I said yes or no, and I explained using a definition. All right, let's look at B. Angle AEB, that's this angle right here. And angle CEB, that's this angle right here, are a linear pair. So let's think about what we know about linear pairs. So what we learned is that linear pairs are two angles that are adjacent and form a line. So those two angles are adjacent. They share a side, they have a common vertex, and they don't overlap or have interiors that overlap. So they are adjacent, and they do form a line. So I can say yes, and my reason is two angles are a linear pair. Oops, sorry, I spelled that wrong. Are a linear pair. I'm on the struggle bus today, you guys. I apologize. If and only if they are adjacent and form a line. All right, and I'm going to go ahead and erase what I drew on my drawing over here. Now, last but not least, ray EA, that's this ray right here, EA, and ray EB, that's this ray right here, are opposite rays. So, what are opposite rays? We learned that they have a common endpoint, which these do. They have a common endpoint of E, and they have to extend forever in opposite directions. And these do not extend in opposite directions. So we are going to say no, and we are going to write the definition. Two rays are opposite rays if and only if they have a common endpoint and extend in opposite, I'm going to abbreviate opposite, directions. Okay, let's go ahead and look at example 6. Example 6 says, rewrite the definition of perpendicular lines as a single biconditional statement. So the definition to perpendicular lines is right here. If two lines intersect to form a right angle, then they are perpendicular lines. So what I can say as a biconditional is, so our hypothesis was two lines intersect to form a right angle. So two lines intersect to form a right angle if and only if. Biconditionals always use if and only if, and remember that is how we can abbreviate it. And that's not something like I made up, it's something that's standard within all mathematical proofs. So two lines intersect to form a right angle if and only if the conclusion is they are perpendicular, I'm going to use the symbol, lines. Okay, I want you to try B. Write it as a biconditional statement. Okay, so the hypothesis is an angle is a right angle. So an angle is a right angle if and only if, and then the conclusion is its measure is 90 degrees. So biconditionals, you take the hypothesis and the conclusion, and instead of having if-then, you combine them with if and only if. And that is what a biconditional is.